Okay, picture this. You launch your new website. It's your baby. And it's a massive hit. People are sharing it everywhere, traffic is pouring in, and then, bam, the site goes down. Now, look, it's a good problem to have, for sure, but it is also a full-blown crisis. Because your big viral moment is about to become a viral failure if you can't handle the load. You've seen it happen, right? Some small website for a new game or a funny video just blows up overnight, and suddenly it's the most popular thing on the internet. And you have to wonder, how does it not just break? Well, the answer isn't magic. It's this really powerful idea called scalability. So let's break down exactly how it works. So we've got a fire to put out. Where do we even start? Well, the very first decision we have to make is a huge one, and it's going to shape everything that comes next. The question is, do we build up or do we build out? Now, the most obvious, intuitive solution is what we call vertical scaling, or scaling up. What it really boils down to is just making your one computer a lot more powerful. Seriously, it's like trading in your trusty old sedan for a Formula One race car. Same number of seats, just way, way more horsepower. This means you're just throwing bigger and better hardware at the problem. You can cram in more CPU cores so it can do more things at once. You can add a ton more RAM so it can juggle more active users. And you can swap out your old spinning hard drives for blazing fast solid-state drives. But there's a catch, and it's a big one. This approach has a hard ceiling. Eventually, you get to a point where you just can't buy a faster computer. It doesn't exist. Or the price just becomes absolutely insane. You can't just keep building a skyscraper taller and taller forever, right? Eventually, you hit a limit. And that brings us to a totally different way of thinking: horizontal scaling, or scaling out. Instead of one giant, super expensive server, we use a whole army of cheaper, regular servers, all working together as a team. Yeah, it's a little more complex to manage at first, but here's the kicker. Its potential for growth is practically infinite. So we've decided to build our army of servers. Awesome. But, now we have a totally new problem. With hundreds of these machines running, how in the world do we direct all the incoming users? It's like opening 100 new checkout lanes at the grocery store. You need someone to tell people which one to go to, or it's just chaos. I mean, think about it. This is the crucial question. When a brand new visitor types in your website's address, how does the internet decide which one of your 100 identical servers is going to handle their request? You can't just leave it to chance. The answer is a brilliant piece of tech called a load balancer. You should think of it as the ultimate traffic cop for your website. It stands right at the main entrance and intelligently directs every single user request to the server that's the least busy. It keeps everything flowing smoothly. Now, the most basic, old-school way of doing this is something called DNS round robin. It's kind of dumb, honestly. It's like a ticket taker at a movie theater, just pointing each person to the next auditorium in a repeating pattern. You go to 1, you go to 2, you go to 3, back to 1. It's simple, for sure, but it's not very smart. And here's why it's a problem. This method is totally blind. It has no idea if server 1 is getting slammed with really demanding users, while server 2 is just sitting there, bored. Even worse, your computer and your browser love to remember things. It's called caching. So they'll grab the first IP address they're giving and just keep going back to that same server over and over, which completely defeats the whole purpose of balancing the load. We've accidentally created this bizarre new one. Our servers now have amnesia. They don't remember who you are from one click to the next. You log in and the load balancer sends you to server A. Great! Server A knows who you are. You find a cool pair of shoes and add them to your shopping cart. Then you click on another link, and this time the load balancer sends you to server B to be efficient. But server B has never met you. It has no idea who you are, so it just asks, "Who are you?" And your shopping cart is empty. It's a total disaster. Well, there are two main ways. The first is called sticky sessions. The load balancer basically just makes a note to send you to the same server for your entire visit. It's simple, but it can cause those same load balancing problems again. The much better, more scalable solution is shared state. In this setup, all the servers share essential memory, like a hive mind. So it doesn't matter which server you talk to, it can look up your info and know exactly who you are and what's in your cart. You know, this is a perfect example of a classic problem in scaling. Every time you solve one bottleneck, you almost always create a new one somewhere else. We've solved the server amnesia problem with a shared database, but now we've made ourselves massively dependent on that one single database. Think about what we've done. We've funneled everything into one single place. Every login, every page view, every add to cart click from potentially hundreds of web servers are all hammering this one database. It has now become our single point of failure. If that database goes down, the entire website is dead in the water. So what's the solution? Well, just like with our servers, we make more of them. We clone our database. A really common way to do this is the master-slave model. You have one master database, the head chef, that handles all the new information. Then it copies that info to multiple slave databases that only handle reading the data. This is great for sites where people are mostly just looking at stuff. For sites with a lot of writing and interaction, you can use a master-master setup, where you have multiple head chefs who can all create new data and they all keep each other in sync. All right, we have scaled our web servers, we've scaled our database, we are so close. The final step on this journey is to hunt down every last single point of failure and build a truly unbreakable system using the incredible power of redundancy. Let's play devil's advocate for a second. What could still break? Well, what if our one and only load balancer fails? Nobody can even get to the site. What if our master database dies? No new data can be saved. What if a random hard drive in one of the servers just gives up? Poof, data lost. Or what if the power goes out in the entire building? Each of these is a critical vulnerability just waiting to happen. The answer to all of these potential disasters is one simple, powerful concept: redundancy. To put it simply, it just means having a backup for every single critical part of your system, sitting there ready to take over at a moment's notice if the main one fails. We have two load balancers, so if one dies, the other one takes over instantly. We have our big fleet of web servers with their shared memory. We have our team of master databases all working together. And we even have a safety net for our hard drives called RAID, which basically spreads copies of your data across multiple physical disks. So if one fails, you don't lose a single thing. We've essentially built a system that has backups for its backups. And there you have it. That's the secret sauce. That's how a website can survive and even thrive when it's hit by the tidal wave of internet fame. But after all this incredible engineering, all this complexity, there is one last question. What is the one single point of failure that no amount of technology, no amount of redundancy can ever truly eliminate? I'll let you chew on that one. Thanks for tuning in.
ありがとう。